Hey engine builder fans, it's Greg Jones. We are here at D&J Precision Machine in Cambridge, Ohio today. I'm joined by owner Drew Pumphrey. And the reason we're here at D&J is this bad boy. This is Justin Zeigler's 6.7 liter Cummins-based Enforcer engine, which D&J of course built. And if you guys have been paying any attention to the diesel world, you'll know that this thing just had a hell of a weekend at the Ultimate Callout Challenge this year. Ran a 4.99 second 8th mile pass and also set a new dyno record. 3,336 horsepower. Hasn't been torn down since that event, and that's why we're here. Drew and the guys are going to get into this engine, see what's up inside, and we're going to show it to you. So Drew, before we get to that point of tearing this thing down, I wanted to ask you just about that weekend that Justin had, and then about some expectations of what you might find inside here. So first off, did you expect Justin to have the weekend that he did in terms of his drag racing and the dyno pull?
It went better than we expected.
Yeah.
That drag racing, they went to testing the week before, got the truck done a little bit late, and they only got through 60-foot hits that whole week before, and they were actually fighting oil pressure problems with this. We put a wet sump system on that we do for a lot of the pullers, and we messed up a little bit and put the sump in the wrong location. And when the truck had enough G-forces out of the hole, it would pull the oil back enough that it was losing oil pressure in the 60-foot. So
yeah.
Justin would shut it down, it lost oil pressure 3 or 4 times. I just told them pretty much, as long as it's not making metal in the filter and it seems like it's all right, keep rolling. They were trying to get their testing done.
Sure,
so we never
sure.
pulled apart after that because it never really made metal. And okay, roll with it.
Yeah.
So going into drag race day, they had not been down the track yet once with the new setup.
Yeah.
So first hit out, they went full pass and they did the 499. And then they fought it after that. Had some nitrous backfires. Nitrous backfires on these things is just extremely hard on them. A lot of times
Sure.
they make a ton of cylinder pressure. They ended up tuliping some valves with nitrous backfires on drag race day, and they come and go, what do you want to do? I said, well, back the adjusters off and we'll roll with it. So they kind of limited themselves on drag race day too, didn't end up making extra passes because they really couldn't gain a whole lot in the points.
Sure.
And they were worried about saving it for the dyno. So
Yeah.
we went into the dyno with tulip valves. We knew that. So I know we're going to see that. Intake side, I think, is what tuliped on this. And
Okay.
we fought that a little bit with the billet engine and finally got an intake valve that'll hold up to the billet engine stuff. So we might do an update here. But as long as they avoid the nitrous backfires, it's really not been a major problem. The billet engine actually got to the point where it was tuliping valves just on horsepower. So
Yeah.
we had to
Yeah.
do something better at that point. But
Now, in terms of Justin's, 3,300 horsepower pull there, was that a range that you thought he could get to?
personally, I wasn't sure that anybody could ever get over 3,000 horsepower
Yeah.
on that dyno.
Yeah.
Through the tire, through the whole thing. I
Right.
knew that we make the horsepower on the engine dyno. Like, really, we had every bit of 4,000 horsepower stacked up on it. I mean, if it was on an engine dyno, I'm pretty confident it would have done that.
Yeah.
But to get it through the tire and get it on the ground is a whole different ball game.
Right.
And when you were running that much nitrous to keep from a nitrous backfire is like, we were like 50-50 shot. It's either going to go or it's going to do the biggest nitrous backfire you've ever seen. And luckily with the Bosch and all the homework Levon and the guys at Firepunk did ahead of time, and Justin did a phenomenal job of driving. He got enough heat in it. That's the biggest thing. A lot of times we don't get enough heat in them and that won't take that nitrous. The Bosch we had set up actually to run the nitrous up electronically. So it had limiters set, so once it would not turn nitrous on unless it saw the EGT and saw the boost pressures that it needed, and then it would trigger the nitrous.
Yeah.
So all that stuff played a big part in saving it because you could have flipped the switch and just all been done.
Yeah.
So
Yeah.
I think it used almost 6 pounds of nitrous in like 1.1 seconds.
Yeah, and I remember Justin, we talked to him at UCC and he was talking a little bit about that, and Yeah, glad he survived the pull is basically what he said.
Yeah.
You know, it could have gone one way or the other.
Oh, it could have been so bad, and that's,
Sure.
I mean, it was hero or zero, and as a team, they just made a decision that that's what they wanted to go for, and the tire selection worked. So feel very fortunate that it all went well. It could have gone the other way so easily.
Right.
So.
Right. Well, Drew, you mentioned a couple of the minor issues that they had throughout that weekend, but as we've seen, history was made at UCC this year, and
they drove it off.
All thanks to what you guys did here with the Enforcer. So let's tear into it. You mentioned a couple of the tulip valves that you're expecting to see.
Yep.
Outside of that, is there anything else that you're expecting that you might find just due to the use and abuse from that weekend?
At that kind of cylinder pressure, that kind of heat, with a quick run like that, I'm probably expecting to see ring tension kind of gone in the pistons. We might see some extra scoring in the pistons because of that. It did seem like it picked up blow by significantly after that hit. Mm-hmm. So that's something that we pretty much really have the customers monitor as an engine wear item more than anything.
Yeah.
That's been the fastest wear item for us, has been piston ring life. And if you get EGTs too high or cylinder temps too high, cylinder pressure too high, it just loses tension. And a lot of times they'll lose tension like instantly, super fast.
Right.
So I'm kind of expecting to see that. It seemed like they had a little more cylinder pressure than they had been. We got a little bit of piston changes we've done with this one, and really all the new Enforcers are kind of getting a little bit of a piston change with wrist pin area. We've had some pin deflection stuff we've been working on. So,
and that's still your DSR?
It's our FSR piston, Ford Steel Ringland.
I misspoke.
Yeah.
Yes.
It's all right. So yeah, it is our FSR piston. It's our connecting rods. Has a stock Cummins crank in it. Roller camshaft.
Yeah.
Billet roller cam. We do all the cylinder head, the intake, obviously all that stuff. Our deck plate setup that we've gone over. So this is this could run coolant in it. We did fill the cylinder head just for some heat soak because they didn't want to run coolant. But when we take the oil cooler housing off and all that stuff, you'll see that the block is set up to run coolant still. Like, it's just air cooled. It has holes through the soft plugs to be able to run a leaf blower through it and cool the thing off faster. It's not full of concrete or anything like that. So this is the same engine that we sell to a customer that could put in a street application that's driving it.
Right. Awesome. Well, Drew, again, we appreciate you having us down, and I think that's enough of you and I chatting here. Let's get into the
see what it looks like.
And see what it looks like. All right.
Sounds good.
All right.
Okay, so first look at all this. Looks really pretty good. We still have crosshatch in the cylinder walls. See how you have black here? That means the ring tension's gone in number 4. Couple different things we're looking at. One is ring tension. So ring tension, you can tell on this piston, this was our best bore. Ring tension's essentially gone away on the top ring. That happens with too much heat, too much pressure. If we keep EGTs under control better, we don't have these issues. This could have happened even on one nitrous backfire. So you can see what the gap was on that ring before it had run and had gotten hot. So if you look to really close detail at the gap, you can see how it's hot at the gap. Fire's trying to blow through there, and the bull nose is gone right at the gap. That's the first signs you have of too much heat and too much cylinder pressure for just too long a period of time or whatever. You look at the back side of the ring, you can still see bull nose to an extent, and the ring's not very sharp. So that means that our oil retention on the bore is good. So the ring's got to run an oil, one to seal and one to lubricate the ring. If your hone surface finish is not correct, you'll see the rings get ate up instantly, basically. And since it has lost ring tension and it has overheated the top ring, you start to see some scoring in the piston. This is all stuff that we'll really look at the ring lands, things like that. If the ring lands all look decent in this thing, I'll put it back in. This scuffing stuff won't bother me a bit. I'll just run it again. But if the ring lands are messed up, then you can't really fix it and you got to move on. But this one here, I would say, is probably fixable with just new rings. And the pin spins, which is good. You can pull all this apart later and really look at it, but that means everything's done a good job as far as that goes. I would say all of our bearing stuff that we have going on there is a couple times we had lack of oil pressure. I don't think it's an overload condition or anything like that. It's the oil system mistakes that we had in the beginning. So we have no fretting on the rod cap, so the rod bolt's done its job. Nothing's moving around there. So all good there. Thing we'll start watching for here is movement between the block and the girdle. We're starting to see a little bit of movement there. When you're at these power levels, you see the bolts moving just a little bit of fretting is what they call that. And that's movement between the block. Our billet main caps are actually have protrusion on the block too, so it doesn't help that any as far as you're squeezing the block together. But at this point, you get past this and you pretty much have to get to billet block stuff. It's gonna break in the cam anyway, so put more perfume on a pig if you try to do more than that. So I haven't seen it be worth spending time and money on.
All right, guys, well, we just watched Drew tear down Justin's Enforcer engine here. And, you know, we already knew about the oil pressure issue, but obviously we saw some wear and some damage from that.
Yep.
But we also saw some other things with the crank walking a little bit. Yep. And stuff with the block and the girdle moving a little. So let's just kind of diagnose that and give folks at home just kind of that re-walk through of what we saw here.
Right. Yeah, we did see a little bit of main cap walking around, which we kind of expected that. That's why we built the billet engine stuff the way we did with the extra main bolts and all that stuff. We had seen that as Firepunk had been racing over the years and put billet main caps in. It gets you to the next level. But once we started breaking the blocks on the cam bores, we just decided that it wasn't worth spending more time, effort, and the customer's money on more and more girdle stuff. If they're going to have problems with that, they're going to have to start getting into some billet engine stuff at that point. Yeah. Because it's going to fail in the cam bore at some point. Like, I wouldn't expect this engine to live at that power level forever. A few hits is one thing. Anyone can do that a couple times, but to get it to last a season at that power level is a whole different ballgame. Sure. So this will fatigue over time and eventually break the block. I'm sure of it. Yeah. So that was what I expected to see there. Oil pressure stuff, it's hard to diagnose 100% if it's an oil pressure issue or just the excessive load from the power it made. We've been really close to the same power level really in other applications and had no bearing issues. Mm-hmm. So I really feel like most of it is the oil pressure issues that we fought, but you really can't say for sure one way or the other since we had the oil pressure problems. Yeah. Pistons were what we kind of expected. Rings had lost tension. The first bore was the best, and 3 and 4 were probably the worst. Means they probably got more nitrous at one point. They could have even gotten more nitrous. Like the backfire could have happened on number 4, the worst. In the drag racing. It might not have had anything to do with the dyno pass.
Right.
So we saw the same answer in the cylinder head too. So valves are tulip the worst in number 6 or number 4 too. So I have seen one nitrous backfire, one boom, lose ring tension, just like that instantly. So we've had engines apart that have had that one hit do that. So that's something that the customers need to avoid as much as humanly possible.
So Drew, obviously we had a lot of bearing wear. You got some tulip valves. We got some, marring on some of the pistons, things like that. When you guys go to rebuild this engine, can you tell the folks, what's going to need to be replaced, what's possibly salvageable?
Once we get all
back out there.
Pistons all the way apart with the rings, we're going to look at the ring lanes and the pistons really good. If the ring lanes and the pistons seem like they're going to be okay, that little bit of scuffing wouldn't bother me a bit. We've put that stuff back together and had virtually no issues. As long as we can get the honed surface finish back in the bores without opening the clearance up too much. A couple 3000s, they'll still play all year. So as long as we can do that, we can reuse the pistons. Obviously new bearings, rings, gaskets, stuff like that. But that's all I'm really expecting to have to do with it. And like I said, hopefully we can keep the pistons too. But if not, we'll have to replace pistons. And
then you mentioned you saw a couple minor things with the crank. Could you still reuse that stock crank?
I think I'd still reuse the stock crank. I talked to Justin about it. I mean, it's definitely gone through a lot of abuse. It could go out the first pass and give us issues because it has so much fatigue on it. So that's up to Justin if he wants to reuse it. We pretty much always throw that ball in the customer's court and give them the best advice we can.
So he could reuse it. He could put a new stock crank in there.
New stock crank in
Or if he's looking to go even more, he could move up to a billet crank.
He could go to a billet crank,
So he's got a few options.
He has a few options there. My guess is with everything we got going on and everything else, he'll probably just want to put it back in and be done with it. Just keep running it. So till it gives us problems.
And then in the top end, obviously he's going to need some new valves. Anything else?
New valves. I wouldn't expect to see anything else. We might touch up the valve job. We'll obviously check, make sure it's flat. We have to resurface it possibly and retouch up fire rings, but all the fire rings sealed good. There was no issues with any of that. Overall, I think everything looks pretty awesome for what it did.
I mean, again, for a pretty fast pass down the drag strip, and for that dyno record of over 3,300 horsepower, it's extremely impressive.
Nitrous backfires,
lack
of oil pressure,
with everything. I mean, the
bearings really aren't even that bad. I mean, none of them got down to copper. They just kind of shined up a little bit. So, I mean, if we measure those, they're probably not really going to have hardly any wear on them. It's just that you can tell that they've touched. So, I'm definitely happy with it.
Well, again, it's awesome to see Justin hit those new heights out there for the diesel folks, and big testament to you guys here at D&J for what you guys have done with the Enforcer and the engineering that's gone into this engine. It does some amazing things, clearly.
We've got like 80 of these out there. So different applications from street trucks to like what Justin's truck is. So it's definitely been a good platform for a lot of people. Broke a lot of records and won a lot of races and stuff like that with this platform. So
well, and to your point, it's got such a broad range of what people can do with it.
That's pretty cool.
Awesome. Well, Drew, again, really appreciate you having us down to the shop. Loved watching you tear this engine down, and cool to see what happens to an engine when it's going through a weekend like it does at something like UCC.
It's amazing how one mistake can just take you out. So at an event like UCC, you got to have a lot of luck too. I mean, like I said, one nitrous backfire and they could have been completely done. And one nitrous, we wouldn't have got a second chance with as much nitrous as on it on the dyno. It would have it would have destroyed everything.
Yeah.
So that thing, I'm just very happy that it went, and those guys spent so much time thinking about, when they can bring it on, and our experiences with making mistakes over the years have kind of got us to where we can make those decisions a little more educated.
Sure. Yeah.
But it's still a big question mark, and yeah, it's pretty awesome.
Absolutely. Well, Drew, thanks again. Guys, make sure you're checking out D&J Precision Machine and everything that Drew and his team here are doing. It's some awesome stuff in the diesel world. And as always, make sure you're checking out Engine Builder for more engine content. And we appreciate you guys watching. We'll see you next time.